Hello guys, welcome to another video. This video is actually not me doing a contest, but me going over a problem that I thought would be worth going over. So, it's called maximum score from grid operations. It is the last question of today's biweekly contest. So if you look at what happened this contest, you can see it is an 8-pointer. And if you look at C-list, this is not necessarily part of the tutorial, but I thought it'd be fun to show that it is quite difficult. It is calculated rating of 2994, so 2900, and I don't think a lot of people got it. I don't know how many people got it. If I scroll down a little bit more, so it looks like only 67 people got it. So, but I assure you, it is not that hard. It is just a bunch of kind of getting all the possible configurations. So let's see, this is proof of my IC, so I'm qualified to go over this problem. So the main idea is to do a DP. Now, how you do DP is going to be, let me just, these hints are not that useful. I was looking at them myself, but then I thought, I don't know, they don't seem very intuitive. So the basic idea is, I'm going to need to draw this out. I'll show you how to catch all the configurations. And don't mind this. So let's say you have like some grid, right? 1, 2, 3, 4, 5, 6, 7, 8. Now I know the way I'm setting up this grid, the optimal answer might be obvious, but the purpose is to show how you can catch all configurations with DP. So there's basically two DPs you have to maintain. So this is DP, this is begin, and then this is DP2, which is the end. Now, what do I mean by this? Well, if you visualize the, okay, so if you visualize the numbers you take, instead of the black cells, you visualize the numbers you take, what you will notice is something like this. I'll just say, so if I were to, okay, so let me first draw the black border. So let's say I take this, and then I take this. So if I just kind of cross these out, and what you notice is it's equivalent to taking this and this. This is a very simple configuration, right? But if I, let's say, get to little trickier configurations, so let me make more space for myself. So if I were to take this, and then this, and then this, right? So all these are painted black. So what does the cells I take look like? Well, it looks like this, this, and this, and this. So what you may realize is you can basically go column by column and just kind of arbitrarily kind of go up like this. Like, now this is technically flipped upside down because in the input you actually starting from the top and then you do something like this, but I'm showing it this way because I think it's easier to visualize, and I just have to flip the logic upside down. So that means I can do something like this. Now say if the grid is really long, right, then so I don't have to worry about painting this here, painting this here, painting this here. It's much easier to deal with them as like steps, right? And same thing for coming down, right? So the difference with coming down is, let's say I start with this, right? I suddenly take everything. Now, how do I come down? Well, I can do this, and I can do this. So it goes down like this. And same thing if I were to go down here, down here, down here. Now, obviously, this would not work realistically. I only need more space over here, but just to kind of demonstrate the point. And then you can have cases like this, and then you can go like that. So you go up to a certain point. So this is your height, and then you go down. So I am not sure exactly what's the best way to describe this, but it's just like if you were to kind of combine everything together, this would just be all one row. So yeah, the idea is to, okay, sorry, let me think for a sec how to describe this. And by the way, this configuration is equivalent to this. Yeah, just visualize the red parts. It keeps going up, and then it goes down some point. Now, that's kind of the main idea. So, like, if you were to say, so let me think. How can I describe this process the best? So if we were to, again, let's say we go up like this, right? So this is, let's say this is dp of, this is dp of 1 and 3. So dp is the column, and how many? Well, that's not exactly accurate. It's like the max height. So after we get to column 1, this is 0, 1, 2, 3, 4. Let me just number columns. So we can just say like dp of whichever column and whichever height we ended at. So this will correspond to this right here. So when we take this element, what's our best answer, right? And then it's also obvious that you apply the reverse logic for going down. So then you have dp. Oh my goodness! Can I move this? Oh, but I can do this. So then you have dp2 of col, and then min height. Right? So, and then if we were to take it down like this, then this is dp2 of 4 and 1. Keep in mind, remember, everything so far is upside down. You have to flip it. But this is basically what we're doing. So now it's obvious that dp2 depends on dp1. So what are the criteria? Well, they have to have the same height. So when you begin going down, right, when you go up like this through the columns, you have to calm down. These have to be the same height. So then, in this case, we have, if we were to try to compute dp2 of 3 and 1, 2, 3, we will obviously look at dp of 0 dot 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 1, 3. Now, in fact, I put this dot 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 because it doesn't have to be just like two columns before. It can be any number of columns before. So 21, 22, 23, 24. So if I were to do it again, and let's say I go here, you can see this is still valid, but this is perfectly fine. And then this would be here 5, and this would be 4. I need to update variables. This is equivalent to taking this so yeah, so this is kind of your main overall transition state. Now the specific cases I'll go over. Now I know this is a little bit of code, so I'll try to visualize what each case I'm going over. So this is the easy case where you go up to some height, and then at some point after you come down. So you can see if I'm computing dp2, and by the way, this j bigger than 0 because we haven't gone up before column 0, so we can't exactly just treat as, we can't exactly just do something like this, right? I mean, that's the wrong color because there's nothing to the left of it. So now don't worry about these plus ones and j plus ones. These are just me being tricky to avoid having to handle lots of out of bound that can just kind of cleanly access the array. So this case is like this is what I was talking about. Yeah, so this is basically what I'm catching. So I look at the possible heights before, so let me move over. Oh my goodness. So if you go up like this, right, then now when you come down like this, you don't have to go down by one block like this, right? You can go down by 3 blocks in one block to select your numbers. So I have to go over for each height how much I can go down, and then I just kind of use the dp of the highest point. So this I2 is basically the highest point, and this I is where I go down to. And by the way, you need prefix sum for this to avoid a factor of n. But yeah, you basically just you just do it. And so that gets that configuration. Now, what is this configuration? This is going over the fact that you can come down more than once. Right? I'm not just always going to take a whole column at once. I'm going to take this much of this column, then I'm going to take this much of this column. Or I can even, do this. So I need to know the height. So I need to know how many elements I'm covering, like the range of height. And I just say, so if this is, well, I guess it's self-explanatory when you think about it enough. But you get a sum of these elements, and then you look at a previous dp that's one higher than you, and then you just repeat this process. Now there's some other tricky cases. For example, if you, let's say you cover it like this, right? Like, I'm not even drawing numbers anymore, it's just conceptually visualizing it. Now, if you have a configuration like this, then you get this number, these numbers, and these numbers. So, as you can see, we've gone up and we've gone down, but we don't have a space before we go up again. So what is this all about? Well, you see, this is actually not the best you can do. In such cases, you can treat this as that, because you literally get more numbers this way. You get this whole entire column. So it's not necessary to worry about the black regions where it goes like, I don't know, something like this. Like, you don't have to worry about this. This is just objectively better, and will be handled by our DP. So in this case, to catch this, so for this is a DP, and then you have another DP here. So there's no DP2 here. So this is not DP2. Because whenever we start a new DP going up, if we were to kind of grab, if we were dealing with something like this, right, and then we start again here. So there's a gap in between DP2 and DP. So there is a gap. But in this case, well, I should say a wide enough gap. Because then with DP2, you're kind of taking this number, and then with DP, you're taking these numbers. So they don't really overlap with each other. But in this case, there's no DP2. You can't exactly have this. You can't exactly take this and then take this again. That would double count everything inside. So here you just say how high you're going with this DP, which is this high, and then go over how high where you gone up. So basically, oh my lord. So DP doesn't need DP2, but DP2 always needs DP for it. By the way, I'm sorry if this is not exactly clear. It's my first time doing this tutorial, like actual legal tutorial, but yeah, I'll make a TLDR. So first DP equals going up, DP of IJ is going up at column I, and have max height J, and then DP2 is going down at column I, have min height J. And then you just kind of get casework it, and you eventually get the answer.